مرحبا طلاب، كيفكم؟ كيف الصحة؟ إن شاء الله تكونوا بصحة وأمان. وطبعا صار شوي misunderstanding على المحاضرات. اتفقنا على بروتوكول معين أنا ودكتور هشام، طبعا بموافقة القسم والعمادة. بعدين ما ضبط، وراح أرجع أحط لكم فيديوهات على أبدي من شابتر 4 وشابتر 3 و2. يمكن أحل لكم كم سؤال وأودي لكم إياها هيك PDF، ونبدي نتواصل على ما يجي جيو. اليوم راح أبدي بشابتر 4 اللي هو transient response. شو معناته transient response؟ كل احنا نعرف إنه أنا إذا عندي input to a system وهاي بي ترانسفير فانكشن G of S، وهاي الاوتبوت عندي C of S، والانبوت عندنا هنا R of S. وانا اعرف انه بهالحالة C of S يساوي لنا G of S R of S، وهنا للترانسفير فانكشن تساوي لنا C على R ويساوي لنا G of S. فطبعا هاي تكون معلومة للجي اوف اس اوف ا سيستم اللي هي البارامتر اوف ذا سيستم، وهاي الانبوت. ناو اف اي انطي الانبوت اشي معلوم، فهذا الاوتبوت هذا عندي الاشي هذا انه ترانزي لابلاس ترانسفورم. ناو اذا اعمل سي اوف تي يساوي لنا لابلاس انفرس اوف سي اوف اس، هذا يسوي لنا اسميه ريسبونس. يعني راح يعطيني ريسبونس بالتايم دومين، واقدر مثلا ارسمه تعتمد على الاوردر اوف ذا سيستم. هذا راح يكون تي، وهنا راح تكون عندي سي اوف تي. اوكي، وهنا ممكن ارسمها هاي اذا الانبوت، هاي الاوتبوت وهاي الاشكال طبعا تعتمد، بعدين راح نفوت بتفاصيلها. واضح؟ اذا الترانزيانت ريسبونس هو الرياكشن اوف ذا سيستم to an input you have to put in here. الانبوت اللي ممكن ان نستخدمها type of input ممكن تكون step، ممكن تكون ramp، وممكن تكون sinusoidal. اوكي، 1 هاي 2 هاي 3. طبعا الستيب هاي شكلها اللي هي they are test signals. They test the system to see how it works. They are not used in real system or in reality, but it's based on the fact that if the system react to this system to this input in a certain way, it will react to different input in the same way. So that's for testing. So these inputs, step, ramp, and sinusoidal, they are test signals. And every time we'll come across these signals, I'll give you how it looks and its Laplace transform and things like that. Okay? Before we go into the details of to get the transient response, and which is the subject of this chapter, we go into some other details, like in section 4.2, which is poles and zeros of system. What does mean poles and zero of a system? Now suppose I have a transfer function G of S equal to S plus 2 over S plus 1 في S plus 4. Where did I get this from? Maybe it was a second order differential equation. Then I put it into Laplace transform. I get something like that. So this is the transfer function of some system. ممكن نقول عليها equal to C of S over R of S. Okay? We are not talking now of slope, open loop, or closed loop. We'll leave this to later in the chapter. Now, what does the meaning of a pole? The poles, they come from the denominator. The value of the pole, how to get the poles? The poles, we get those S plus 1 times S plus 4 equal to 0. So it's S equal minus 1, S equal minus 4, right? If I substitute here for S the value equal minus 1, what do I get here? I get here a 0. So division this over a 0 will give me infinity. Then the poles give the transfer function a value of infinity. Okay? So these are the poles. The poles, this we say poles of G of S. When we go into Laplace plane, we'll have the poles presented as like that. Poles equivalent to cross. Okay? The poles are equivalent to cross. Now, what's the meaning of a 0? And the meaning of a 0, we have G of S again equal S plus 2 over S plus 1 times S plus 4. So I'll take the 0. I say S plus 2 equal to 0, S equal minus 2. Now, if I substitute for, I hope it's clear. I substitute for S equal minus 2, this will give me 0. So the 0, that's the value of the parameter or the value of S in the numerator that will make the whole thing transfer function equal to 0, right? So the 0 make the transfer function equal to 0, poles make the transfer function equal to infinity, right? Rames 0 equivalent to like that, round. Now, if we put this on the S plane, now if I go like that, this is J omega, this is, this is sigma, this is J omega, this is a complex plane, I call it S, you put something like that, S, and we put a square around it. So if you put this, that means this is an S plane. Now if we represent this on the S plane, we say minus 1, minus 4, let's say go like that, minus 4, and we have minus 2. So we have a system with 1 0, which is here at minus 2, this is minus 2, and 2 poles at minus 1, minus 4, right? That's the meaning of pole and 0. The pole and 0 of the system, especially the poles, they are the roots of the equation. If you have a differential equation and you get the roots, and so these are the poles. And of course, poles and 0 will be an important matter that we'll go through always in our lecture in this chapter and the subsequent chapters. For example, let's take another example. Let's say we have G of S equal 1 over S plus 2, S plus 3, S plus 4. So it has only poles. So if I put S equal to 2 minus 2, that will be infinity. If I put S equal minus 3, it will be infinity. So we have poles, we say S equal minus 2, S equal minus 3, S equal minus 4. On S plane, this is sigma. Sorry, maybe it's this, I'm away from the camera. This is J omega, this is sigma. So if I come here, of course, we'll learn later that this S plane have an imaginary axis, this one. It has right hand side of S plane and hand side of the S plane, and all these have a meaning. We'll come across this meaning later in the chapters. So for this system, we have minus 2, minus 3, minus 4. That's we call pole 0 representation of a system. And you can go into MATLAB. It has an instruction called pole 0 map, and you can use it, and all that is available in the book. So if I have another simple example, a first order system. Let's say 5 over s plus 2. So it has only one pole, minus 2. And that's it. That's j omega, and that's sigma. That's the meaning of pole 0 for a control system. Sorry. Let's take an example. I'll go into other details like this is example in the book. The example said that I have let's say C over R equal S plus 2 over S plus 5. Let's say that R of S يساوي step. If you remember the Laplace transform, a step means that it's a constant. A step is higher R. It's like that. If it's a unit step, then it's 1. So then R of S in Laplace, if you remember, we talked about Laplace before, or if you remember, you take in Laplace. For here, R of S يساوي 1 over S. For here we have, remember, this is what? G of S. Right? Now we have R of S equal 1 over S, which is the input, times G of S. Sorry, forget about this. R of S equal 1 over S, then C of S equal G of S R of S, as we said, and then C of S equal S plus 2 over S في S plus 5. Right? Now we practice how to get the transient response of this as it's like introduction. We go into other details later. So because I have real poles and zeros, this I can say it's equal to A over S plus B over S plus 5. As we all know, I hope we all know, but we'll do it. Okay? And by Cook method, A equal S plus 2 over S plus 5 when S equal to 0, that one. Substitute for S equal to 0, we'll get يساوي 2 over 5, right? Now B equal S plus 2 over S when S يساوي minus 5, right? Now this means that B equal to minus 5 plus 2 over minus 5 and equal to 3 over 5. Okay? So we have ينتج عندنا إنه C of S راح يساوي لنا 2 over 5 على S plus 3 over 5 times 1 على S plus 5. Right? Of course, I can put this outside and this one outside. It's okay. So this one is a step. Okay? What يساوي? And then using, let's say, Laplace transform table, then C of t راح يساوي لنا this one is a step mean 2 over 5 plus 3 over 5. This is an exponential e to minus 5t. If you look at this this part is I hope you can't see my fingers. This part is due to the step, and this part is due to this one, which is part of the characteristic of the system. So this one, we call it, this is a transient response, هذا response. Okay. This one I called it force part. Force part. This one I call it natural, whatever you call it, I don't know. Natural part or response. So this is forced response, this is natural response. You notice that this natural response is an exponential. For as t grow, as we grow in time, as t become big, this will vanish. It will become 0 because it's something to minus. So e to minus 5 times t, let's say 10, it will become very, very small. So at t, as t goes to infinity, let's say t goes to infinity here, we'll have this will go to 0, and what will be left? It will be left this one, 2 over 5. 2 over 5 in a shape, it's like the input step, it's a constant. But as a value, it will differ because it depends on the system. It doesn't get the same value as the input. Right? If we can plot this simple plot, that's t, that's c of t. So if this is the input here, 1, which is the input u, the output will be something like that. The output is 2 over 5. It's far away from 1, so it's not equal to the input, but in shape at steady state, that means when t goes to infinity, this value of the output, it will be similar to the input. It's a constant value, right? Okay.